Welcome to Foo Café and DevOps Skåne. Today we're going to talk about, or David is going to talk about cloud computing as a utility. And I'm just going to say welcome to all of you. This is the agenda. We did the meet and greet. David is going to do a presentation, pizza, drinks, you know the drill. And as mentioned before, this is meetup number 50 since 2018, so it's been around sometimes. And we are the organizers of this. Before we start, I just have a quick question, so raise of hands. Who here came here because of Foo Café advertisements? And who here came from LinkedIn advertisements? Cool. And that's basically it. We are everywhere. And yes, thank you. So one question. Is there anyone here who doesn't want to have their face published on social media? Say now or... Cool. David.
Albert, thank you. Let's see if the HDMI still works. Okie dokie. Mirror the displays. Yeah, absolutely. There we go. I need one more thing. I forgot my clicker, so I'm gonna have a long wire instead. There we go. Almost. Let's start over. Right? This is what we're going to talk about today. I've given this a lot of thought. I'm going to go through my thought process of how this came about to be, and then some of the stuff that I've been working on after having these revelations. My name is Söderlund, as you may or may not know. I titulate myself as a platform engineer. I live in Simrishamn with my family. I am really interested in computers, and essentially I like to build stuff that works. I like to talk to people that build cool stuff, and I want to help them. And I really, really like Kubernetes. So this is going to be a lot about Kubernetes. Is there anyone here now who does not use or know what Kubernetes is? Is there anyone here who would be nervous if I pointed to them and said, can you explain Kubernetes to me in 5 sentences or less? Yeah, me too. All right, cool. So we'll see where we end up with it. But this is the type of talk where you just interrupt. You get the microphone from Albert and you ask questions whenever you feel like it's either going too fast, it's going too slow, or going in a direction where you no longer feel like you're part of this and understand what we're talking about. All right? I'm very up for open discussion to tailor this into something that makes sense for you and is valuable for you. All right, so this entire thing about some sort of open source hyperscaler or like cloud computing as utility started with a discussion that we had over LinkedIn a couple of months ago at this point. An old colleague of mine, Dejan Sarka, he wrote, and he's the type of person that speaks truth to power. He's not afraid to speak his mind. He's a Microsoft MVP for very many years, probably decades at this point, and he is a bit pissed off with Azure and Microsoft because of the stuff that they're doing now with the way Trump is handling our data in the cloud. So he basically said that you should really think about your data strategy if you are concerned about regulations in the EU and your customers' data. So when I read all of this and took it in, I replied something to the line of, hear me out, we build our own, right? Just build it. How hard can it be? And so we started out as a joke, and then we actually talked about it and said, all right, what is it that we need to do to be able to actually do something with this? So the way I see this problem is that, of course, cloud computing is dominated by large proprietary platforms. The incumbents in America, also IBM, of course, and then there's Huawei and Tencent and AliCloud, others, AWH as well in Germany. There's some French ones. They're pretty big, but it's not super transparent how they work and everything. Once you pick a provider, you will find that you might get teased into choosing them, and the rates look pretty good. Then somehow your rates go up, and you're not really sure why, and it's kind of hard to get out. There's also something called egress fees that is very fun to try to explain when people want to shift from one provider to another. Yeah, we already covered that. And I also noticed another thing, that maybe some larger enterprises want to run their stuff on-prem, but they're a bit worried that if we buy too much compute, are we actually going to be able to utilize all of this? Maybe it's better to choose cloud so that we can scale in a different way. I'm going to try to address this as well. So this is special for this talk. Since there are some people here, is there anyone in here who actually likes using cloud over on-prem? Yeah. Anyone who's very hard preference the other way around? Never cloud. All right, cool. Have you ever found anything in one vendor where you were surprised it didn't exist in some form on another vendor? For example, some sort of functionality that is either completely missing or very different to set up. Because if they're all the same, then there is really no problem. You can just take your Azure stuff and just run it on Amazon, right? Kinda. Is there anything that you've built using multiple cloud offerings that you're not very proud of? This is me as well. Stuff from one place to another. All right, maybe less common. And who here wants to bet that their weird thing is the weirdest thing anyone in this room has ever done? Is there anyone who thinks that that's them? I don't think it's me. No? All right. This is basically saying, is there something that you feel like, oh, I am probably the only person that ever done this. If I had a talk on this, it would go on for 50 hours. No. All right. Food for thought. So the way I imagine cloud computing, it should work like a public utility. And we want to be able to put our workloads anywhere with one sort of standardized declarative configuration. I would like there to be an ability for other companies to act like vendors, maybe even private people with their compute, to be able to sort of rent out extra capacity. That would be sweet if someone can have a job they want to run. I have some extra compute here, run it there. That'd be pretty cool. That way we can have price discovery and that kind of stuff. And essentially lead to some sort of free market for cloud infrastructure and seamless portability, which sounds very cool. So what would that sort of entail? What do I mean by utilities? Infrastructure as a public service. So when I say work like a utility, I think electric grid, roads that we drive on, railroads, that kind of stuff. Because it's subject to regulations and maybe public ownerships. Things, the standards that we already use. Sort of like we already have HTTP, we have TLS, we have other standards that are defined and everyone agrees on how they should work. Is it possible that we could have something similar for the way that we configure our cloud infrastructure? And then we're talking about interfaces. We all know what these are. I really like this part. It allows for good abstractions. It's easier to think about things if we all agree what they mean. So this is my toaster. I have it at home. I like it very much. This one has two interfaces. This is the one that most people think about. The slots are always all the same width of every toaster in the world, so that all of the bread fits. Nobody builds a toaster that's this wide, and nobody makes bread that's that wide that's supposed to be toasted. It's standardized. Very nice. But today we're going to talk about this interface. This is actually really, really powerful. A lot of smart people thought for a long time about how are we going to be able to put different types of appliances into our walls and have that work securely without us all having to be electricians. And that's the sort of analogy that I want to use throughout this part of the talk. I don't have to be an electrician to make toast, but I do have to be some sort of DevOps wizard to be able to deploy my software on the internet. And I find that is weird because a lot of people make a lot of software, but there's sort of this gate to be able to have a secure software deployment, which is sort of what I want to address. Does that analogy make sense for everyone? Or is it like, weird? Okay, cool. Open source hyperscaler, what do I mean by this? There are already a vast ecosystem of a lot of different open source tools that does a lot of stuff with cloud, but there's sort of still the step over to being able to run whatever we want, wherever we want, and just move it seamlessly in between. Kubernetes has gotten a long way, but it's sort of still about container orchestration and not so much of the other stuff. I want to build on top of Kubernetes and extend it to other things. I also want to perhaps run it as one cluster with some changed out parts, for example, the scheduler, so that we can have multiple, even competing vendors in the same cluster. Again, this is just, back of the napkin how I want it to run. This would then allow you to be able to schedule your workload depending on your compliance requirements. So if you, for example, say, I want to run this workload in Sweden, I want to run it in south of Sweden, maybe I want to run it anywhere in Europe is fine, lowest bidder, you could sort of write on your specification that that is what you want. Ultimately, I want it to lead to some sort of model where all of the different providers or upstream vendors can compete on cost or performance or whatever other metrics that is important to customers to attract customers to them. Sort of like a stock exchange, right? Whoever bids the lowest on price, they will probably sell the most and so on. All right, enter strong moves. So this is my sort of startup almost, or well, we've not incorporated, but we've at least written a business plan. I thought about it for a long time. We imagine ourselves as maybe being a wrapper of some of the Swedish providers for services, so that you could use us to then not have to, so we still have this abstraction layer, but we would then offer that as a service. Could be one thing. But as some place to start to be able to reach this long-term goal that I have, some sort of vehicle to get there, attract people and so on. We think of ourselves as, this is our sort of goal. We want to be a multi-cloud orchestration platform, basically meaning can we be the sort of gate to which you, or the de facto standard of how you apply for getting cloud infrastructure and then scale that out to the different providers that we vet. Long term also, of course, those standards would be open for everyone, so whoever wants to run a similar node somewhere can do that. All right. So how would this work in practice? I imagine that we set up some sort of control plane. So we have a API that you can talk to. If everyone knows sort of how Kubernetes works, you write your YAML and you send it to somewhere. That YAML can express anything. It's taken in by the control plane. Make sure that that desired state is replicated to all of the database nodes. And then there are operators in there that sort of reconciles that state. But instead of just doing containers, we can do whatever abstraction we want, really. I'm going to, in my demo later, show one such abstraction, how that could look in terms of implementing any abstraction. I imagine that we can have almost like a reverse auction, like we do with the electricity in Sweden, where the providers tell me, hey, in this hour I'm going to have this much capacity, I want to sell it for this much. And another provider might say something else. So then when I go to push my toast down, I don't have to call up a power plant and say, I need some electricity. It just works, right? Because that's already been taken care of. Imagine something similar for our cloud infrastructure. So if I say, I want this job done by Friday, it's gonna fix itself. I don't have to sort of coordinate myself. That's what I mean by like job execution here. This is sort of what I'm after. So Kubernetes, we have our little control plane in the middle, takes all of the requests for change of the desired state. If we, instead of having just worker nodes and control nodes, we actually imagine, let's schedule worker nodes, but we actually provision them on different vendors. So this might be, for example, Elastic's, this might be SafeSpring or Klura or some other Swedish provider. We join those nodes into our cluster. Long term, I imagine they could then sort of enroll nodes and say, hey, on these different hour blocks, we will have this type of availability to help with the scheduling. And then some happy guy like me says, I want to run some sort of job. The scheduler would, schedule it on nodes just as in any Kubernetes cluster, just that the specification might be a little bit different, or the way we read the specification and choose where to schedule it might be different. So we could have some sort of job that says, for example, I'm going to run Spark. I'm going to run some script. Here's my token so that I can reach the storage that we build, whatever that might be, inside here. And then, of course, I want this done by tomorrow. We got to figure out how do we actually measure what a unit of work is, like a DTU in Azure, and fix some sort of course, fall back on like, okay, it ran for longer than it was supposed to. You know, you have the halting problem. Even though we have Turing completers, we can never figure out how long something is actually going to take to run. So you might want to, if it for some reason, we wanted to halt it sometime. But this could be like an actual specification of something. You can imagine that I'm sending, hey, do this for me using this platform. I don't care where it runs. Figure it out, right? So that is an actual use case. So the control plane would then match the buyer, my job in this case, with a seller. And then I would use my tolerations on the job to say, for example, where can my data live? If my data can only live in Sweden, it's going to respect that. Time boundedness, of course. I want my job done by some certain time. If I say it's okay if it's done by next year, maybe I'll get a lower price because, you know, sometime during that, the prices on computers probably going to drop. And yeah, maybe I have some preferred list of vendors and so on. The control plane or the cluster will inject. What's it called? Anyway, we're going to make sure that we have the correct telemetry to be able to actually facilitate so that the vendor who actually executes the job gets the appropriate amount of compensation, just like when you buy and sell shares on a stock exchange. And this model will also say that, for example, we might have customers that do want to scale up. They might want to scale out, but maybe they actually don't choose to do that for some reason. Maybe there's not enough traffic. If vendors then make their nodes available, they can still get paid by that for that capacity. All right, so we're gonna hold it there for now. That is sort of the vision of how I want this to be. There's not much actual stuff to look at. It's mostly about creating some thinking around this and sort of see where, of course, there's 100,000 things that could go wrong for each and every of these interaction between entities. There are at least 15 different things that need to work. But none of this is actually impossible. Some of it may have a long tail of how hard it is. But really think about it. What would it be like to live as a developer or a DevOps person in a world where we have like vendor-independent cloud? All right, make sense? Anyone so far have any sort of direct feedback of this is impossible, I don't like it, or hey, this is great? No? All right, then you're subjected to still hearing me talk about it. So I had some ideas for some prototypes. So if I wanted to build a business, we can go one of two ways. You can either, you know, hyperscale up yourself, seek funding, attract a lot of talent, build something really quick, and then just burn money for a long time. Or you could grow organically, which is my preferred way of doing stuff, where you actually find real people who are willing to be parted from their hard-earned cash and build some services for them that they might use, and then try to do it in such a way that you reach your actual goal with the stuff that you add on in terms of features. So that's something that I'm working on right now, just trying to see, hey, would you be interested, if you're using Azure in this way, would you be interested in trying this and so on? And what would you be able to pay for that? Other things one can do is, for example, if anyone's used upload thing, an SDK for uploading to AWS S3, no? Or maybe Tigris for also S3 compliant storage, no? We could also build something like an app hosting solution, like Railway.com or Fly.io, if anyone's ever used those, or Heroku, if anyone still uses that. That might be attractive for developers, for example, easy to get started. I'm really interested in like identity and access management, so I'm thinking I want to build something in and around that if I can attract some customers. If anyone else has any idea of, hey, this is something that I use on AWS or Azure or Google, but I'd be interested in running something similar if it was available and only ran on Swedish providers. So if you have any ideas like that, you can come to me afterwards and bring it up. Right. How are we doing on time? Okay. So I'm going to hold a short demo where I've built an abstraction, right? So we talked a lot about, okay, we're going to run something in the cloud, but we're going to express it through easier means. Well, what do I actually mean by that? So for another forum, I've built another demo. I'm going to borrow parts of that. So remember, we want to run everything on Kubernetes because it is the best way of having an API, best way of having a distributed storage for your desired state. We're going to introduce the concept of composition through crossplane. If anyone here has used Terraform or Pulumi, has anyone also used crossplane? comparatively. All right, so Crossplane is basically a operator for Kubernetes that lets you do infrastructure as code, but with like continuous reconciliation. So instead of having to run Terraform apply all the time, it does that for you. It also allows you to express, just like as with Pulumi, into basically anything you can run through a container runtime to express how you want it to look. So you can write your custom Python or Go code or whatever it is to just code your infrastructure as code. So it's not just infrastructure as data. We're going to take a little look at that and build two different abstractions that I call app and full stack app. Then we have CNPG as an abstraction for databases. Allows us to run Postgres on Kubernetes in a very nice way. We're going to skip maybe parts of API gateway, but we want to be able to have some sort of ingress to our app, because if we put something on the public internet, at some point we might want to surf to it, right? And then we're just going to use Argo CD and Backstage to visualize what's actually going on. Cool. So here's my sort of user story for this. As a developer, I want my 12-factor app to be reachable over the internet, but accessible only by those that I choose, so that I can collect quick feedback on the app. Make sense? I don't want to send someone a link to localhost 88 and say, what do you think? So we're going to start out by creating what I call an app. So that's our first abstraction. We're going to have, how do we actually, what is it actually that we need to say about an app when we create it? Might have a name, might run some sort of stack, might need a container port. It's going to connect to a backend. That's going to run another framework. I chose .NET because I like it. It in turn is going to connect to our database, which we're going to create with CNPG. And in front of all of this stuff, we're going to put some sort of ingress. This is sort of the full stack app, as I imagine it, where we just tell it, all right, what's our front end running, what's our back end running, how do we actually inject the secrets for the database connection into the back end, and so on. Oh yeah, before we go to this slide, I actually want to have a look at this. So this is something that I created earlier today, I think. Can you read this, or should I make it even bigger? There we go. So this is my full stack abstraction, and you can see it has these four parts that we talked about. One backend app, one front-end app, ingress, and database. Is there anyone here who really hates YAML? All right, because I think it's a pretty good analogy. But this is basically the API, right? YAML and JSON, they're interchangeable. And when you send a manifest to Kubernetes over its HTTPS, you're basically doing a postman put, right? So it is the API that we're going to use. And we express the database, and the only thing you really need to say is how many replicas do you want. If you don't want a database, you would do this, right? Perfectly fine. For my ingress, what do I really care about? Well, I want to be able to surf in on some sort of address, and that's basically it. This is going to point on the front end. You don't have to really specify that much. For my front end code, I'm going to run some image that I've already built. I'm going to give it some sort of container port, so just that it knows that the traffic that hits it is going to actually do something. And the number of replicas, and similarly for my backend, there might be some other stuff. For example, I'm telling it, and you can just give me the database connection values as environment variable. My code will handle it. You might do it in different ways where you actually want to specify which environment variable gets what, but we're going to skip that. So this for me feels like a nice way of thinking about a full stack app. If I can tell you what images do I want to run, which host name do I want to go to, and that I want a database, that should be sufficient, right? Cool. Oh yeah, we're going to do a normal app. So when I talk about app, that's also an abstraction. So I just want to highlight that we can build like abstractions of abstractions. So let's say I wanted to build a Foo Café app, right? It's going to run on some container port. And let's see, what were I going to use? Oh yeah, the first Easter egg, Albert. We were talking about is anyone familiar with the term Rickrolling? So someone posted a Docker image for this, and I thought it'd be funny to try out. So what image do I need? I need this image. And port 8080, perfect. There we go. And we want to name it Foo Café. I'm going to save it as some file in my repo here. I just name it, I don't know, Foo Café. There we go. And now I'm just gonna make sure I'm in the right namespace. So again, if you don't like writing kubectl commands, we're gonna show that you can of course do an abstraction on top of this interface to have some other GUI in the future. I don't expect every customer that finds cloud hard to then be able to sit and run kubectl. It's just an analogy. Kubectl apply Foo Café.yaml. You need to be able to spell. Did I not? I must have put it somewhere else. Oh, I put it in the root of that folder. Never mind. Let's move it. It's good if you put the stuff in the right stuff. Let's try again. Okay, so now Kubernetes tells me your app of type crossplane of Söderlund Consulting Foo Café has been created. Very nice. Which means that here we have an app. It's called Foo Café. It's there. It's not ready yet. We're just going to take a look in the console and see why it's not ready yet. Okay. Deployment. I don't know if you can read this. Maybe it's a bit small. I'll zoom in a little bit. It's basically my abstraction in crossplane here, basically keeping track of the different resources that are subcomponents of this app abstraction and saying that the deployment and the service and the ingress that you want are on their way to be deployed. So now it has turned green and it says true, which means this is on. So now I need to check which hostname I put for it. Oh yeah, and I closed the file, so it needs to be here. Foo Café. Oh yeah, there was one more thing I needed to do. Actually, we'll do this. We'll do it one more time just because that was so much fun and because we have so much time. I'll remove it. I'm actually gonna do this via GitOps instead. So I'm gonna take this and put it next to my other app that I did before and just put this here. And oh yeah, I need to check my we're talking about crossplane before. It's not just for making like your own abstractions and using them. You can also use it basically as an analogy for Terraform. So I'm actually gonna update my keycloak realm here so that I can take traffic on this host name and just make sure, because otherwise I will not be able to authenticate, because my sort of keycloak installation will say that you're not allowed to surf to this app because that's not an approved redirect URI, if that makes sense. And if you don't care about the identity and access management, you can skip that part. Okay, so we're gonna check that in. We're gonna check Foo Café in and say added Foo Café. Who here uses GitOps, by the way? 1, 2, all right. This is basically me putting my desired state configuration of what I want to run in my Kubernetes cluster in Git. And that means that this app that I'm using, Argo CD, can help me keep track of how I changed my desired state configuration. It can also help me synchronize. And it also has this very nice little interface that I can use to sort of see what's happening. So now that I've added the Foo Café app, it's going to say, well, your desired state is that there should be such an app, but I don't see it. So when it synchronizes, it creates that, which then leads to the creation of these other sub-particles here, my service, my deployment, and my ingress. So that's basically what I mean by we can build any abstraction in Kubernetes for some other thing that Kubernetes doesn't support natively. Now I'm just building other Kubernetes native resources, but I also did a little change to my keycloak, so I'm going to go in and sync my management platform as well. Actually, I could do it by Argo CD app sync management platform, just to make sure that the ingress actually, otherwise I will get an error when I connect and say this is not a valid URL for your platform. It's already in progress. That's great. So let's go back. We get a little link to our little app. And of course, only those with access should be able to, this is not publicly available. I mean, you can surf to this address, but you're not going to be able to see it unless I give you a login, which again is according to our user story that we had there. And if we're lucky, we're going to get rickrolled. Perfect. So it could be any image you want, is basically the point. So as a developer, I have some app, here's my code, run it. Cool. I'm going to remove that because even though it's fun, it's still ridiculous. We'll leave it up for now. It's fine. So that's sort of to recapture all I need to sort of, if I built a nice abstraction, it should be easy to follow what I need to fill out. Of course, it also is described if you want to run something like to watch this API schema. How many minutes? Very good. Other than this, I can't really think of anything that you should have to put in to get something to run, which is often the first hurdle you want to get over before you start changing things. So I think it's pretty elegant. This app is a full stack app. So this has a database and an ingress, but it also has 2 apps. So we already made something called an app, and now we're building something that uses that app. That's also pretty elegant, because then I have this separation of concern. So for my front end, same thing. I'm going to have some sort of image, some number of replicas, some port. And for my back end, again, I'm going to add a little bit extra because I want to inject environment variables and so on. And then my database and my ingress. And very similarly, we can have a look if we minimize here and we look at demo 2, the app that I created here beforehand. And it very elegantly has these 4 different parts. One app called backend, one app called frontend, ingress, and a database cluster. And that's all you really need to know. I imagine that you're not going to jack that YAML directly into your Kubernetes cluster. It might instead be something like this, right? You might use some form. In this case, I'm using a template in Backstage to just even more simplifying the ordering of this. I feel like this is very analogous to like going to a bar and saying you want a beer. Like it shouldn't be much more harder than that. You shouldn't have to say, oh, take the glass, pour that, do this, I'm going to be over there, and then do the dishes. No. Name, ingress, yes, database, please. And out it pops, you know, the orchestration of creating this into GitOps. And then I have my app. This app, not very advanced either. It is a little shopping list app because it's just an example of what you can do. So I'm hoping, did Mikael go for the pizza and the beer? The beer is already here, so we're going to check that. And then we're going to have vegetarian and salami pizza. And also, what else do we need? We maybe need some water. Cool. So we can just see that this is an actual functioning app. It actually commits this stuff to the database if we want to go in and look at it. The reason I'm showing this is not how incredible this is. I actually didn't even write it. I asked ChatGPT to write it, but I showed it my abstraction, and it figured out how all of the other stuff should fit. So that's also sort of a nice receipt that your abstractions make sense. Cool. Let's see. What else did we have in mind? Oh yeah, no, that was probably about it. All right. Any questions on like crossplane or abstractions or how any of this stuff works? Anything that confused you? Daniel, you get the mic.
Yes, you mentioned earlier the vendor agnostic parts and competing on prices.
Yes.
How does that connect to these abstractions?
Right. So if we that part with the abstractions of what you actually push, not so very much. That's a different separate part of StrongMoves, where it's more about being able to bring in nodes. So if I take a look at the nodes that I have in my cluster, you will notice that these are all things that I've named. These are all running on my hardware in my lab. But you can imagine that you enroll other nodes. And you can taint these nodes or give them different labels on what they do. For example, this node is a bit special. It's a bit bigger. And it says GPU on it. This is because that's the one node in my cluster that has a graphical processor on it so that I can run machine learning workloads. Similarly to how this is labeled for GPUs, you can imagine that you set other types of metadata to describe which vendor they belong to, maybe a cost center and so on. Other type of taints that they might have that, oh, it's maybe not a AAA grade storage speed or whatever it might be. So there's 2 ways we could enroll under vendor nodes. One would be that we use their publicly available OpenStack implementations through Crossplane. So we would, for example, say, I would like there to be a VM. This wouldn't be an end user requesting a VM. It would be our platform saying, I need more stuff. I want to put it over here. So there is a Crossplane provider for OpenStack, and we say, create a node, then run this script on it to enroll it into the cluster with the labels and the annotation in such a way that when the scheduler that actually puts my beer buying app on it, it might choose that node. Is that an answer to your question?
Yeah, I get it.
All right.
Clearer picture, yeah.
Okay. All right. If anything else come up, just take the mic. Anyone else? What is Crossplane? So it is an infrastructure as code solution running on Kubernetes so that you have reconciled desired state configuration. Just like you schedule workload for anything else, you might reconcile. In my case, I changed how my keycloak realm works. So I can have that in Kubernetes manifests and treat it with a kube API. So for me, it's a way of bridging the gap between desired state config that and actually putting it in practice. It doesn't do digital twins really, because it's like it treats it as the source of truth and tries to reconcile. You can also set it into observe only mode. So if you have existing infrastructure, for example, Azure VMs or something like that, you can observe them and bring them into the fold. You can even see them inside Argo CD if you want. But you won't act on them. I use it for a lot of the different, lots of different open source tools that I use in my platform. I hook them up with Crossplane so that I can use a simpler configuration language than to, for example, run shell scripts and other stuff like that. You can imagine, for example, if you are a platform team and you have developers that build maybe very complicated systems of many services that need to work together, and they have some sort of end-to-end test where they want to run either a pen test or just hit a lot of workload through their API gateway. You could imagine you set up an abstraction that creates an entire ephemeral environment, an entire Microsoft Azure tenant with a resource group and an AKS cluster, for example. You could build something like that, and then you would just say kubectl create cluster. Or you could have that as part of your CI/CD pipeline. Anything basically you can do with Terraform, you can do with Crossplane. We might, if there's interest for it, I can show other stuff at some other time, I guess, with that, or we can talk about it afterwards. All right. Any other questions on what you just saw in the demo, or about Strongbows, or about cloud as a whole? No? All right. So what should I do next? I want to build a prototype of something and actually make it work. The case I've shown now is for something else, but I thought it fit the bill. I want your feedback to be able to find a use case where something I can provide value to either developers or to other enterprise users, and something they might need that fits the bill. Another thing we could do all together is to drive political interest. Think buy European, and of course attract people like you to come and help me with whatever it is. So that's what I'm spending a lot of my time on. Cool. Thank you. I'm done.
Any more questions or any words?